Hello everyone, this is our session 14 on indefinite integration. We are beginning with integration by parts. This is the second part of the chapter. Before this we had done integration by substitution method. Okay, now we're doing integration by parts. So there is a theorem on integration by parts. Let us look at that theorem first. Okay, so what does the integration by parts theorem say? If u and v are functions of x, then integration uv dx is equal to u integral v dx minus du by dx multiplied by integration v dx into dx. Okay, now, one second. Okay, integration du by dx into integral v dx dx. Okay, now what does this mean? So u and v are two functions. Okay, like it could be trigonometric and exponential functions together. It could be algebraic functions and trigonometric functions together. Okay, so u and v could be two different functions. Now when they are multiplied and then integrated, how do we understand how to integrate this kind of a combination? So you need to find out which amongst this is a direct integral. That is, how would you know that, let us say you have two functions u and v, out of which let's say v is a direct integral. That means I can directly use a formula and write its integration. Okay, so then we use this theorem to solve these kind of sums. That is u integral v dx minus integration of du dx into integral v dx dx. Okay, so this is how you are going to integrate it. Now let's first prove the theorem and then we will look at the sums. Okay, so for proving, we say that let v dx equal to w. So I'm using, or I'm making use of a third function. I'm calling integral v dx as w. Therefore dw by dx will be v. That is by definition of derivatives, or you can say definition of integration also. By rule of derivatives of products of two functions, I'm taking the derivative of which two functions now? U and w. D by dx of uw is equal to u dw by dx plus w du by dx. This is for derivatives. Okay. Now, what is dw by dx from equation 1? It is v. So uv plus w du by dx. Okay, now this is the derivative of uw function. Okay, the next step will be by definition of indefinite integration. Okay, what do we understand? So if we have derivative of a function with us, how do you write the integration of the same? So we say that if d by dx of uw is this function here, then integral of this function will become uw. That is integration of uv plus w du by dx. Okay, dx is equal to uw. Okay, this is how we write definition of indefinite integration. Okay, now let us split the integration sign. So it will be integral uv dx plus integral w du by dx into dx equal to uw. Okay, now what is du by dx? We can write this as one second. Okay, so we can now, if you know that, we require this term over here on our left hand side in the to prove that. So we write integral uv dx is equal to uw minus integral w du by dx into dx. Now wherever we have w, we will substitute it. What is w? Integral v dx over here. So what is w? Integral v dx. So let us put integral v dx everywhere. So we have integral of two functions is equal to, it's the first one, uw, that is u integral v dx, okay, minus integration of du by dx, okay, we'll write that first, into integral v dx, the whole thing, into dx, hence proved. This is your theorem by parts. Okay, what does it say? If we have any two functions, algebraic, logarithmic, exponential, trigonometric, any of these functions, then how do we integrate them together? So if we have integral u v dx, then we write it as u integral v dx, first step, minus integration of du by dx into integral v dx dx. Okay, so basically in the second part there is a differential, that is you can say f dash of u, okay, into integral v dx dx. So we are going to use this theorem to solve the next sums. Okay, please do the proof as well, it can be asked for the exam. Okay, now the problem here will be the types of functions that you get or you come across. So we have a rule for that. Okay, we are using this rule over here. It's called the Lie-8 rule or LIATE rule. Now, what is LIATE? So it's the order in which you can solve, or you will say that, you do not know which function do I take the integration and which function do I take the derivative. So we are going to use this sequence LIATE. What is L? Logarithmic. Okay. What is I? I stands for inverse trigonometric. Okay. Then A is algebraic. Then T stands for trigonometric. And E stands for exponential. Okay, so this is the order in which we can take the integration of products. So I'll just read out something to you. When the integrand is a product of two functions, out of which the second can be easily integrated. Second, here we consider the v function can be easily integrated, that is whose integral is known. We can use the rule of integration by parts. Hence, we should make a proper choice of the first function and the second function. Okay, so the order in which the two functions are to be taken as the first function, the second function, is according to the serial order of the word Lie-8. Okay. Okay, so whenever we have these combination of functions, what do we take first function as and what do we take second function as is the order in this letter word here, LIATE, Lie-8. Okay, so first logarithmic, then inverse trigonometric, then algebraic, trigonometric, and then exponential. So your first, let's say if we have the combination of algebraic and logarithmic, then our first function would be logarithmic and second would be algebraic. Okay, that's how you will remember the order in which to take the integration. Okay, so when we solve the sums on the same, it will be more clear to you. Okay, so let us try to use this integration by parts for a proof sum. Okay, so let us try and use it for integration of e raised to ax sine of bx plus c, okay, dx is equal to, we have to prove this equal to e raised to ax upon a square plus b square, okay, bracket a sine bx plus c minus b cos bx plus c, okay, plus c constant. So that is always going to come in an integral. Okay, there is one more of the same type, but let us first solve this one in using the integration by parts. Okay, so how will we solve this? Let us take the left hand side as LHS is equal to, okay, I equal to integration of e raised to ax sine of bx plus c, okay, dx. Now remember what rule we have to use. We have to use integration by parts. So we'll say by integration by parts, integral u v dx, okay, is equal to u integral v dx, okay, minus integral du by dx into integral v dx dx. Okay, so let us use this by integration by parts for our sum. So LHS is equal to, or we can say I is equal to, okay, u v dx. Now e is an exponential function and s is a sine is a trigonometric function. So what is the rule? Exponential and trigonometric. So trigonometric is considered as the first function and exponential is considered as the second function. Okay, so what we'll do is, instead of using, since we know the derivatives of both, integrals of both, you can take any of them as your u and v. So I'll consider e raised to ax as u and v as sine bx plus c. Okay, so let us begin. Okay, so let us start. This is u here and this is v. Okay, so u v dx is u integral v dx. So e raised to ax integral sine of bx plus c, okay, dx. First part minus integration du by dx. So d by dx of e raised to ax, okay, into integral sine of bx plus c, whole thing, or rather let's put a round bracket here, this dx, because there's an integration sign outside. Okay, let's integrate this. So I will be equal to e raised to ax. What is integration of sine? Minus. So e raised to ax as it is, minus sine. Sine becomes cos. So minus cos bx plus c divided by b. Correct? Yes. Now plus c1 will be there, but we can write that in the end, or if you want you can write it over here, plus c1. Okay, now minus integration sign is there, so I'll put that integration sign. What is derivative of e raised to ax? It is a e raised to ax, okay, into what is integral of sine bx plus c? It is minus cos bx plus c divided by b, okay, plus c2, or just put any constant here. There is, see, there is already a integration sign which we haven't yet done, so we'll not write plus constant, we'll just take this outside. So we have equal to minus e raised to ax upon b cos of bx plus c as it is, okay, plus c1 as it is. Now here we have minus and minus becomes plus a upon b integral e raised to ax cos of bx plus c dx. Okay, Now what we'll do is, this part is already done. Okay, we don't have to fidget with it. We'll do the integration of this again by using integration by parts. So we'll have I equal to minus e raised to ax upon b cos of bx plus c. Okay, plus c1 as it is, plus a upon b as it is. So let's put a bracket now. E raised to ax cos of bx plus c integration. So again uv dx. Okay, let's say we will call this as u and this as v. Okay, so we'll say first term e raised to x u integral v dx. So integration of cos of bx plus c. Okay, dx minus integration, and then we write du by dx. So d by dx of e raised to ax into integral of cos of bx plus c. Okay, and this whole thing into dx. Yeah, okay, let us find the second part integration. So we'll have the first parts as it is. So I will be equal to minus e raised to ax upon b cos of bx plus c. Okay, plus c1 as it is. Okay, that is your first part. 1 second. Yes. Now a upon b will also be written as it is, bracket e raised to ax as it is, derivative, integral of cos of bx plus c dx will be sine of bx plus c. Okay, upon b plus c2, integration done, that is why. Okay, minus sign as it is, so minus integration sign, derivative of e raised to ax will be a e raised to ax. Okay, integration of cos of bx plus c will be sine of bx plus c, right, upon b. Yes, and dx. Close the square bracket. Okay, so how can we write this now? So if you can observe this portion over here, e raised to ax sine bx plus c dx. What is that? That is your integral, right? I. It is your I over here. If you want to check, you can go see, is that I? So yes, it is integration e raised to ax sine bx plus c, correct. So that is I. So what we'll do is, we are going to write that in the form of minus e raised to ax upon b cos of bx plus c, okay, plus a upon b square e raised to ax sine of bx plus c, okay, minus a upon b I, or rather a square upon a square upon b square. Now why a square? So if you can observe this a upon b here, okay, gets multiplied to each of the terms in the square bracket, right? That is why we get a square upon b square. Now we'll go back to integral I. So you have two i's here, one on the left hand side, one on the right hand side. Let's get them together. So we'll have I plus a square upon b square I, okay, equal to, here you can have, let's say, minus, or you can say a upon b square common, okay, a upon b square common, e raised to ax common. And what do we have in the bracket? So we have sine of bx plus c. Okay, the second term is positive, so sine of bx plus c minus, if let's say if we take a square upon b square common, then what do we get? So we have, okay, 1 second. Okay, so I have taken e raised to ax upon b square common. Okay, now if you observe, if I take that common on the right hand side, then in the first term I will be left with, since there is a denominator b and I have taken b square common, I have to multiply the numerator with b. So minus b cos of b x plus c is already there here. Okay, then in the second term, e raised to ax upon b square is common, so I'm left with a sine bx plus c. Okay, that's what I have written over here. Okay, now let's solve the left hand side. So the left hand side will be I common, okay, 1 plus a square upon b square, okay, equal to e raised to ax upon b square common bracket a sine bx plus c minus b cos bx plus c plus c. Okay, now when you take the LCM, b square from both sides will get cancelled and I will have I b square plus a square, okay, equal to e raised to ax and the whole bracket over here. Yeah, so what we'll do is we'll keep I here and we can write this as e raised to ax upon a square plus b square, okay, and the bracket a sine bx plus c minus b cos bx plus c plus c. What is I? It is integration of e raised to ax sine of bx plus c dx, okay, is equal to this bracket here. That means we have proved the LHS equal to RHS. Let us check the RHS once. So what was the RHS? Integration e raised to ax sine of bx plus c dx is equal to e raised to ax upon a square plus b square bracket a sine bx plus c minus b cos bx plus c plus c, that is your constant. So here we'll put c as c1. The reason being we already have c in the brackets over here, so we cannot use the same alphabet. So we'll call this as c1. Okay, yeah, so in the final answer also it will be c1. E raised to ax upon a square plus b square a sine bx plus c minus b cos bx plus c. Okay, there is a similar kind of activity, or you can say problem, to solve in your textbook regarding e raised to ax cos of bx plus c, and you have to prove that as e raised to x upon a square plus b square a sine bx plus c plus b cos bx plus c plus c1. Okay, so try that proof as well. Okay, if you do not understand this, you can write to me. I will explain it again to you. In this session, we've only explained what is integration by parts, and I've done one activity on it. In the next session, we begin with the exercise. Thank you so much.